A 216 square meter rectangle pea patch is to be enclosed by a fence and divided into two equal parts by another fence parallel to one of the sides. What dimensions for the outer rectangle will require the smallest total length of fence? How much fence will we need it? Alright. First of all, we have a rectangular patch that we're trying to fence. And it says 216 square meters. What is that? Meters squared. If you think about it, the units are squared. What is this information? This is actually the area. They are telling us the total area of our patch has to be 216 meters squared. They say it's going to be enclosed by a fence and divided into two equal parts. So if we draw a fence right down the middle, technically it doesn't matter if you draw it vertically or horizontally, we get the same answer. I'm going to do it vertically for you. Two equal parts. Alright, so if this is a rectangle and this side is an X, we know that the other side is an X. What does that make the line in the middle? Gotta be the same thing. This is a rectangle. Alright. Well, what do we call the other sides? Well, because we put that middle piece smack dab in the middle, made it two equal parts, we can call these other dimensions Y if we wanted to. That'd be the easiest way to do this. Let's see, what else? What dimensions for the outer rectangle will require the smallest total length of fence? Now the fence, remember, is every single side and that middle piece. So how much fencing do we need? Can't call this perimeter necessarily because they have to include that middle section. So if you want to call it F for fence, you can, or you can call it P for perimeter. Just remember, you have to include that middle piece of fence as well. So how much total fence do we need? Let's add up all those little pieces of fencing. So there are 3 X's worth of fencing, and there are 4 Y's worth of fencing. That's how much total fence we need. How can I relate this amount of fencing to my area that I'm required to have? Create an area equation. How much area is inside of this fenced off region? We know it's 216, but can you write that in terms of X and Y? The area formula is the length times the width. Well, one dimension of our rectangle is X. The other dimension is Y, so 2Y. So X times 2Y. Or you can write 2XY if you want. So with that information, I've got random answers for this. Let's move down. There we go. Now it's not all squished in there. So my area is equal to 2XY. Now, what are we trying to do? What dimensions for the outer rectangle, for X and 2Y, will require the smallest length of fence? So we're smallest. What does that mean? For us, that means that we're trying to minimize the fence. If we're trying to minimize something, we in calculus use the derivative. So let's take the derivative of fence. Oh, wait a second. We got 2 variables. Who would we take the derivative with respect to? Alright, well, let's back up. Before we take the derivative, can we use some algebra to try and get rid of one of the 2 variables? Well, we do know some information about the area. We know that the area is 216 square meters, and we know the area is 2 times X times Y. So can we use that information, 216 equals 2XY, to get rid of one of our letters? Use substitution. If we solve for one of the letters, let's solve for Y. That means we're keeping the X's. So divide by 2X. Let's see, that would be 108 over X equals Y. Now we can plug that into our fence. And our fence equation becomes 3X plus 108 over X. One variable, so now we can take the derivative more easily. Before you take the derivative, rewrite it. So I'm writing this as function notation because I'm OCD. The fence function is a function of X. It only has X variable. So I'm going to rewrite it. I'm going to use algebra because I want to bring that X upstairs before I take the derivative. So now, what is the derivative of this function? Alright, 3x, the derivative would be 3. And then the second term, power rule. So negative multiplied by 108. And then our new power is 1 less. Now, as I warned you, you need to clean it up. Get rid of that negative exponent because you have to set this thing equal to 0. Derivative equals 0 is your critical point. Remember, critical points are your potential max and min values. So we have to solve for x. Alright, so how are we going to solve for x here? I'm going to bring the 108 over x squared around. And then I'm going to get rid of the denominator by multiplying both sides by x squared. So we end up with 3x squared equals 108. Divide by 3. X squared equals, it's 108 divided by 3. 36. How do you solve for x? How do you do the square? Take the square root. But when you put the square root on, you have to put plus or minus. So x equals plus or minus square root of 36 is 6. And what did we just find? We found the dimension in one side of our rectangular fenced region, our, what was it, p-pad? P-patch. Alright, so we found this dimension here. Cool. What's wrong with this picture though? X could be positive 6 or negative 6. Can you measure a length of fence with negative numbers? Absolutely not. So we actually cannot allow for the negative because it doesn't make sense to measure with negative values. And what was it? What were our units? Meters. 6 meters is that dimension there. Question asked you for the dimensions. So we also need to find the other dimension. So x is one way. The other dimension, based on the way I drew it, was 2y. So the question is, what does 2 times y equal? Well, we've got to find y for that. So let's go back. How did we relate x and y to each other? There it is. Highlight it. So this right here is the relationship between x and y. To find y, plug in the x you just found. So y is 108 divided by x. Whoop, yeah, so I did plug my x in, and we show the steps. So 108 divided by x. So in our case, that's 108 divided by 6. 108 divided by 6 is, good question. 9. No? Okay, just do it. 54 divided by 3. 18. Right? So then the full dimension of the base of our rectangle is going to be 2y. So 2 times the 18, or 36 meters. Alright, so this is why I need you guys here to keep me from making silly mistakes. So I made a big mistake back here. So when I plugged in y, I totally forgot about that 4 in front. So let me go back through and fix that. So 4 times 108. I'm sorry, I started over recording again, but a lot of recording. So 432. We end up with 432 here. Of course, I did it differently than I did in my notes. And then we get 432 here. I need to check my answers. Always check your answers. And then we get 432 here. 432 here. So 432 divided by 3 would be 144. So we have 144 in here. the square root of 144, we can also find that's 12. Yay! Okay, that fixes my problem. And then again, we take positive answer. So I'm sorry, I did that mistake. Hopefully, half of you caught that and fixed it when you saw it. Alright, so if that's my x, then I need to divide by the correct x in my y equation. Which means my y is going to be 9. Okay? Yes. So then if I plug y in here, my second dimension has double of the y, so it's y and then y again. So we have 2 times 9, or 18 meters. So the dimensions of the box, or the fenced area, are 18 meters by 12 meters. And then it asks us for how much fence is actually needed. So the amount of fence, you recall, was, go back up, 3x plus 4y. So 3 times x plus 4 times y. And we end up with 36 plus 36, or 72 meters. Now this is not meters squared, this is just the fencing. It's not area. Right? And there you go.